call this session. All right, so welcome to this demo in which I will show you how to create a computer vision model in like 5 minutes. But the interesting thing about that is not only the model, but how to leverage the output of the model. So what I'm going to do is going to show you a little bit on the website that you can use to train a model in like 5 minutes, as I mentioned earlier. And then I will show you how to download that model and use it locally. So first of all, what I'm going to do, as I said, I'm gonna show you a little bit around. So the first thing that I'm going to do is go to the website, which is named Teachable Machine. If you're on board in this project now, you will have a link for this website. If not, just type in Google Teachable Machine, and yeah, you will see the first link that will redirect you to this website. This is a fantastic website. This is a great website in which you can just train a model in a matter of minutes. And yeah, let's get started. So as you can see, you can use image projects or basically train a model based on the images from your webcam, or you can also use your microphone. And in this case, you can also take a look at a model that will basically be trained on different parts of your body. So you can make different positions, and it will detect what position are you taking at what moment. But now what we are just going to do is a simple image project. And this image project, first of all, you will have the option to choose the standard image model or the embedded image model. So the standard image model is the one that you can use when you are using your computer. So if you're using just a normal computer or a laptop, this is going to be the one to go. But if for some reason you are using a microcontroller, such as an Arduino or Raspberry Pi, something like that, something that doesn't have a lot of memory, then you can go with the embedded image model. But in this case, yeah, I'm using my computer, so I'm gonna go with the standard image model. And first of all, one question for everyone. So who can tell me what's a classification model or what's a classification algorithm? Don't worry if you don't know the answer, that'll be fine.
An algorithm that gives an output, a fixed output.
Okay, okay, so what do you mean by fixed output?
Well, predicts rather than a numeric output, a fixed output.
Exactly. Yeah, it will predict a label or a class. So that's the reason why it's called classification, basically. And instead of, as Christopher said, instead of predicting a continuous value, for example, the price of a house, for example, it will just predict whether something belongs to class 1 or whether something belongs to class 2. And yeah, the difference that the name for the first model is called regression, and the name for the second model, the second type of algorithm, is classification. So in this case, we are just going to predict whether something belongs to a class or to another. And in your project, you are going to predict, or you need, let's say that you need to predict whether the image that you are showing to the camera belongs to class rock, to the class paper, or to the class scissors. So I'm not going to run through the same process as you. I'm just going to show you an example, and then you will have to apply something very similar to do your project. In this case, first of all, I'm gonna stop my video on Zoom, because otherwise my webcam is not going to work on this website. And I'm gonna upload it. Cool. Oh. All right. So what I'm going to do now is I'm just gonna put my Fab app in case something is good. just to say that something is good, or I'm going to put my thumb down in case something is bad. And don't forget to add a third class just to show that the image doesn't belong to any of those classes. So now I'm just gonna say in this case, this is going to be the class good. This one will be class bad, and this one, let's say neutral. Okay. And if you're a little bit familiar with machine learning or deep learning, I don't expect that you are, by the way, but if you're already familiar, you will know that the more images you use during training, the better the model. That's the reason why is because basically the model will have more samples to to tell apart the two different classes. So if my thumbs up, the model will know or will have more samples to know, to tell that like this sort of image of a thumb up will represent a good class, and on the other hand, with more images of myself just pointing down, then the model will know that it will try to see some patterns in the images that will help it detect whether something is good or bad. So the more, as I mentioned, the more images you use for training the model, the better. So let's try to use some of them. Well, I'm not gonna spend like the whole evening just recording myself. So I'm just gonna press here on hold to record, and with different images of myself, just with my thumb up, just try to put different angles to your hand. Let's say different sizes of your hand. I mean, different depths. Okay, I think that will be enough. Let's go with the bad one. In this case, I'm gonna show my thumb down, and we'll repeat the same process. Maybe moving a little bit behind just to capture more images. I think that will be enough for now, and just a neutral in which I'm not going to show my hand. Just gonna move around just to. All right. I think that will be enough. So let's train the model, and this is going to do everything for us. We don't have to program like the neural network that is going to train our model. We don't have to set any weights. Everything is going to be given by this website. So yeah. And you will see that, it will basically take 1 or 2 minutes tops just to train the model that will help you detect whether something is whether your hand represents bad or good, or nothing if it doesn't take a hand. Okay. Yeah, you can see that it's going to be that is super fast, because now the end result, it's quite fascinating to just to think about it, because in like less than 1 minute we can have a model that can detect whether we're saying good or bad. And look at that, it's incredible, really. I think I run this demo for like I don't know how many times, or I've been doing this for I can't remember how many times, but I'm always fascinated about it. Well, all right. So now that we have trained our model, it's time to export the model to our local machine. So one way to you will see that we have many options. We have TensorFlow JS, which is basically an embedded code that you can use to put on your a website. If you are, for example, developing a website and you want someone to get access to your model easily, you can copy paste this code and put this HTML code inside your website, and anyone can get access to that model anytime. But what we are going to do now is basically download the normal TensorFlow, which is the one that we are going to run on our local computer. And also, just as a side note, if you want to download something, or if you want to download this model into a small microcontroller, such as a Raspberry Pi or maybe an Arduino, you can do that by using TensorFlow Lite. But for now, as I mentioned, we're going to use the normal TensorFlow. You will see Keras or you will see Safe Model. We'll just go with Keras, which is the API of TensorFlow. Oh, sorry, and by the way, TensorFlow is one of the biggest deep learning libraries that you will find out there. So you will find PyTorch, or you will find Caffe, or you will find TensorFlow. TensorFlow, as I mentioned, is one of the biggest deep learning libraries developed by Google. And yeah, usually it's as far as I know, it's more used on production, whereas PyTorch is more used in research. But ultimately, yeah, I couldn't tell which one I prefer, because I've been working with both, and yeah, both of them work very, very well. Okay, so enough talking. Let's try to put this into a local computer. As I mentioned, we are going to download the Keras model. And yeah, now it's going to be converting the model to something that we can download. In the meantime, what I'm going to do is create a new virtual environment. So let me clear this out. And oh, sorry. Opening converted. Let's just save this file. I will open that eventually. Okay, so if you have already installed Miniconda or maybe Anaconda, you should be able to see something like this on the left-hand side of your terminal. If you're on Git Bash, or if you're on the terminal on your Mac or Linux, you should be able to see something like this. This is basically the name of the virtual environment that you are currently in. But I really can't stress this enough. If you are using or if you are onboarding a new project, make sure to create a new virtual environment. So that's what I'm sadly going to do. I'm gonna create a new, I'm gonna zoom in a little bit. And I'm gonna all right. So I'm gonna create a new virtual environment by using conda create name, and in this case I'm gonna name it Teachable, for example, January. If in case you don't know what a virtual environment is, a virtual environment is going to be some sort of room in which your packages are not going to interfere with the base or with the rest of the packages from like the base environment or different environments that you have in your computer. Everything that you have inside that virtual environment will not have any impact on the rest of the packages, and the other way around. The rest of the packages are not going to have any impact on the packages you have in your virtual environment. And one of the reasons that you want to do this is because you will eventually have a lot of different, and I can't stress that enough, a lot of different packages. And some of them, it's quite likely that they have some sort of conflict. So in order to avoid that, just create a new virtual environment and give it a proper name, like something that you will remember. For example, in this case, I just name it Teachable January because I'm using this for using Teachable Machine with the January users. So that's something that I will easily remember. So I'm gonna activate it now. By the way, if at any point you have any question, just please interrupt me. I think we have plenty of time today to go through any questions. Okay, so you will see that my virtual environment is activated because on the left-hand side on my terminal, we can see Teachable January, which was the name of the virtual environment that I wanted to use. Okay, so now that we have, okay, sorry, I know that there are some people writing on the chats. if I can be on like reading both things. So if you just if you have any question, just interrupt me. Just raise your voice and let me know what the question is. Okay. All right. Well, yeah. In that, or otherwise, I will just go through the questions later. Later when as soon as I finish everything. So now that we have activated our virtual environment, let's see what we have inside. And the way to take a look at the packages that we have in the virtual environment will be typing conda list. And this will give us the list of packages that we have in that virtual environment. We can see that we don't have anything. So let's install a couple of things. The first thing will be pip. Conda install pip. Yes. Okay. Now let's take a look again at the list of packages we have. Let me open this a little bit. Okay. Yeah, we can see that we have some new packages, and we can use pip to get started with TensorFlow, which was the library that we are going to use to run the model that we have just downloaded. So let's go with pip install TensorFlow. And by the way, I think in the instructions that you have, it will ask you to also install Keras, but it's well, I think most likely Keras will be installed by default when you install TensorFlow, because as I mentioned earlier, Keras is like the high-level API of TensorFlow. Okay, so in the meantime, while this is installing, I'm gonna open VS Code. Actually, I'm gonna open a new one. Let's see how this is going. All right, so this one it's already open. And okay, now that we have we already have the virtual environment and TensorFlow installed. Oh yeah, sorry, we need to install another thing, which is OpenCV Python, and this library will help us using the camera on Python basically, which is basically what the base of the project, right? Like using your camera to play rock paper scissors. Okay, so in case you're not familiar with the terminal or Git bash, just a couple of notes here. As I mentioned, this thing here on the left-hand side is going to be the name of your environment. If you don't see anything here on the left-hand side, that means that you are not using Conda or mini Conda, sorry, Anaconda or mini Conda. You are just using the Python interpreter to run Python. Here's my username, and here is the name of my computer. Then this $sign, if for some reason you don't see it, don't worry. It depends on the shell that you have activated. If you have bash, or if you have the regular terminal from Mac or Linux, you should also be able to see this $sign. Okay. Oh yeah, sorry. And this tilde thing, this tilde thingy here, it's representing home. So that's basically my home, my home directory. You can take a look at what we have inside. This is basically what I have in my home directory. But what I want to do now is going to desktop, and from desktop I will create new directories in which I will just set my workplace for this demo. So to change to a new directory, we use the command cd, that stands for change directory. So cd desktop, and we can see that now, yeah, the list of files that we have in desktop has changed from earlier, because yeah, we are in a new directory. Let me clear this out, and I'm gonna create a new directory. I'm just gonna call it teachable January. And now you can see that a new folder has appeared here. So I'm gonna move inside, And this is going to be now the place that I'm going to start to work. So I'm going to open VS Code, and I'm going to add that folder to workspace. Let's go to desktop and yeah, Teachable January. Cool. And now that that has been added to VS Code, we should be able to see that on this tree here on the left-hand side. Cool. So right now it's empty. Let's add a couple of things. The first thing that I'm going to add is a notebook, which I'm going to call Teachable. And a notebook has the following, sorry, let me zoom in a little bit. Cool. A notebook has the following extension, IPYNB, that stands for Interactive Python Notebook. And if everything works fine, you should see a different, some sort of different logo here. In this case, this logo represents the Jupyter Notebook one. Okay, so now that we have this notebook open, we can select a kernel, which is basically the virtual environment in which we want to run our notebook. I'm going to use the one that I just created, which is called Teachable January. Cool. And if everything went well, we should be able to import, CV2, which is the library corresponding to OpenCV Python, and that will help us to use the camera in our in Python. And the other thing that I wanted to import was from keras.models import load model, and this is going to help us load the model that we have downloaded from this website. And let's open that, by the way. So here on the zip file that we have downloaded, we have two files, keras model h5 and labels .txt. So let's extract that, and I'm going to extract that in the same folder that I just created. Extract. Okay, show the files. Okay, there we go. So we have 3 different files now. There we go. Okay, so if everything went well, we should be able to say model is going to be equal to load model. And in this case, the name of the model that we have is called keras_model. Keras_model. Let's run that. And it will ask us that, yeah, we don't have IPyKernel installed. So let's install, install. Let's install IPyKernel, and most of you have already installed that. It basically will allow us to run a Jupyter Notebook in VS Code. This is going to take a while. So, oh, that was fast. Okay, cool. So if everything went well, yeah, the model should be working fine. So that's if you reached this point, then everything should be working smoothly. But okay, I don't have the, I think, okay, just give me a second because I don't want you to see the solution. I'm gonna copy this. Oh, well, no, the solution, this is actually a template. It's actually a template, but just in case. And this is a template that you already have on the file that I sent to you. Okay, so this, let me explain just very quickly what everything means here, or at least the most important things mean here. We have cap is equal to CV2 video capture, and at this moment, cap is going to store, let's say the image. Well, not the image exactly. It's going to be an object that will control the input of our camera. So when we say cap.read, that means that at that moment it will take the image and it will transform it into an array or a matrix of numbers. Each number of that matrix will correspond to the number of so an RGB, so red, green, blue color. So sorry, and as you can see here, it will consist of a matrix of dimension 1 times 224, 224, and 3. This basically means that we are going to have one image per frame. Well, not per frame, per iteration here, because we are going to iterate indefinitely until we press Q. So we will have one image per iteration that will consist of 224 pixels width and 224 pixels height. And these three represent the number of channels we have. Each channel will represent a color. So as I mentioned earlier, red, green, and blue. And all of this here will just help you normalize the pixels. Don't worry too much about it. This is going to help us basically fit the model into the fit the images into the model. And finally we can have the prediction, which we can see that's basically obtained by saying model. Okay, so predict the output based on the image that we are passing here, and then just show us the image. Just show us the camera, or the camera is capturing at that moment, and then I'm just printing the prediction. So I'm gonna stop the webcam here, and I'm gonna run this. Cool. Now you can see that Python is capturing my image, and it's showing some images here. It's showing some numbers here on the background. Basically, this is printing out at each iteration. It's printing out the output of the model. So the first item. Well, let me just explain really quickly one more thing about classification. Classification is not just going to give you 1 or 0. It's actually going to give you the probability of an image to belong to a certain class. So the first item here represents the probability. Well, sorry, let me just highlight this one. This one. Okay, for some reason it's taking all of them. But yeah, the first item represent the probability of the image belonging to the class good. The second item corresponds to the probability of the image belonging to class bad, and the third item corresponds to the probability of the image belonging to the neutral class. So you can see that most of them are just in most of them, the third item is the closest one to 1, which is the highest probability in this case. The rest are very, very low. So we have to take the highest value on this and then translate that into whatever we want to, translate that into the classes that we have. So for example, if I put my thumb app, the first item should be the closest one to the unity value. So if I put it like this, you can see that now the first item is the closest to 1. Now, if I put my thumb down, the second item is the closest to 1. And if I don't do anything, the third item is the closest to 1. So let's see how to leverage that output. I'm just gonna take a look at prediction. And I'm going to, don't worry if you don't understand this right now. I'm just going to explain the high level logic of it. So prediction is going to, I'm just going to make a logic flow here in which I will say if the first item of prediction, remember that Python is 0 indexed. So if the first item of the output here is, let's say, greater than, I don't know, 0.7, just print good. Now, elif, if that's not, if that doesn't happen, but the second item is greater than 0.7, then print that. And if none of those conditions happen, just print neutral. Okay, so yeah, now you can see that's basically neutral because I'm not doing anything. But as soon as I put my thumb up, good and bad, good and bad. All right. Yep. I think that went. Yeah, I think that went well. I think I had covered everything, and I don't want to take much of your time because I said that I was going to spend like 30 minutes. But I hope that was useful. I tried to cover as much as possible for getting you started with the project. But as always, any questions more than welcome. I'm just trying to think, am I missing something? I think not. I think not. But yeah, if you have any question, please go ahead. Just let me know about any question. I'll stay here a bit longer.
Awesome. So we're meant to be working in our groups now on this project in breakout rooms, or just smashing it on our own, staying here?
The idea will be, well, you can smash it on your own, but the idea will be go to your breakout rooms and just work along with your teammates. Just in case you have, for example, some issue, or maybe you want to share some ideas, or yeah, you have any doubt, you can always ask your teammates. And if you want to share like some sort of exchange, some sort of ideas, that's always a good idea.
Cool. And so how long are we doing that for? Sorry to ask so many like new
questions. Yeah, no worries at all. So the ideally, if you can if you can complete this project in less than two weeks, that would be great, because that's more or less the time that you will require to finish the Python programming module. Then you will onboard the next project, which will consist of web scraping, the web scraping project.
I meant in terms of tonight. If I'm going into the breakout room, obviously I've booked out until like 9:30 and stuff, which is great. But for the rest of the evening tonight, there's no more back into a room together sessions.
Oh no. That's usually when we have some sort of demos or gatherings or meetings, we put that in the agenda.
Lovely. Okay, so yeah, I'll be jumping into room 12.
Cool.
And getting on with that.
All right.
That was amazing, though. Thank you. Absolutely mind blown in terms of training that model. That was fantastic.
Yeah, I know, right? And it's super easy, and you can just record yourself on a video, upload that to your social media, and you will draw a lot of attention for recruiters.
In terms of the model that's just been trained, how good is it if you get that model that you've just trained with the green screen background and your face in it, and you give that to someone else? How good is it at detecting the differences with the hand and not just being blown away by the total different context? Yeah,
that's a really good question. In this case, you can see that, yes, you said all of the images have my face in it. So it's going to be very specific about training that. If it doesn't detect my face, it might be a little bit confused. Sure. That's what you call overfitting. You are going to train the model, and it's going to learn so much about a train set, that when you put that into production, it's not going to know what to do. Sure. So it's not going to do.
As a cohort, if we were to get our models, is there a way of merging the feeds from all the different cohorts that we've got so that it's playable by a more diverse subset of people?
Yeah, that's actually one of the ideas of training machine learning models, or deep learning models. You are going to try to make your samples as diverse as possible. Obviously, you don't want to add some noise to your model, like, yeah, this is not representative of your sample, but within your sample, or within the expected samples that you can find in your population, then it would be ideal if you can just take as many or as much diverse, the more diverse the sample, the better. That's basically what I wanted to say.
Yeah. All right. Good. Well, see how we go. Thanks very much.
Cool. Yeah. Any question? Feel free to ask.
Yeah. Hi. Hi, everyone. I have one question.
Okay. Yeah. Sure.
This Teachable Machine website. Which models is it using? Like, which algorithm is it using?
Oh, do you mean in terms of, for example, ResNet or Alex or something like that? Or, to be honest, I'm not sure. I haven't read the papers. I just know that they are quite easy to. It's quite easy to use. But
I mean, there are a number of algorithms like SVM and neural networks.
Oh, in this case, it's a neural network. The only problem is that I don't know the exact neural network, because right now there are so many neural networks out there that it's quite difficult to know exactly which one we are talking about. But in this case, it's not SVM, for example. It's not support vector machine, or it's not random forest. It's actually using neural network.
Right.
But as I said, well, probably AlexNet. It's not it, because that's a quite old one. But yeah, it probably is one of these that you can find in the TensorFlow zoo. So for example, if you go to TensorFlow zoo, you can see here a lot of different neural network structures.
Okay.
So probably it's using one of these. Not entirely sure, but it's quite likely one of these or something very similar.
Okay. And where we can find the recordings of the sessions?
Sure. Right now I will tonight I will upload it. I will just upload it to YouTube, and I will send you the link. And I will also send you the link for a playlist where we will upload the videos corresponding to the demos that are more focused to you.